Today in Algebra I, we talked about sets, set notation, and subsets. Here I've got two sets, A and B. These are in roster form. A roster form is simply a list of all the elements. So in A I have 5, 10, 15, and 20. In B I have 5 and 10. Today we talked about figuring out whether a set is a subset of another. The way we know that is if every element in one of the sets is in the other. So in this case, in roster form, it's quite simple to see that B is a subset of A because every element in B is also in A, and that meets the definition. If I were going to write this, I would write B is a subset of A. Remember, this is my notation. If I were to make a Venn diagram, it would look like this. I have 5, 10, 15, and 20 in A, and then in B, I have 5 and 10. So the elements of B are within A, so B is a subset of A. Sometimes it's easier to see this visually. Here I have set A and B. These are different sets. And here I've got set builder notation. So this says X such that, remember that line means such that X is greater than or equal to 4, and X such that X is greater than -2. Here I want to figure out which one is a subset of the other. When I'm given inequalities, sometimes the easiest thing to do is create a visual representation or a number line. So over here I have my number line. A is all of the numbers that are greater than or equal to 4. B are all the numbers greater than -2. So here we see that A is within B. Every element of A is also in B. That means that A is a subset of B. Today we talked about figuring out whether the vice versa was true. So in this case, B is not a subset of A because there are elements between -2 and 4 that are in B that are not in A. So by the definition, B is not a subset of A. We only have one or the other. Now, what happens if both of our sets are equal? Let's say that set A is 1, 2, 3 and B is 1, 2, 3. This means that A is a subset of B and B is a subset of A. And we can also say that the sets are equal to each other. So if A is a subset of B and B is a subset of A, that means that our sets are equal to each other. Today we also talked about figuring out the number of subsets. So not only identifying whether something is a subset of the other, but identifying all of the subsets. So in the case that we have a subset such as this, where I have A is a set of A, B, C, and I want to find all the subsets. The first thing I do is find out the number of subsets I'll have. Remember, that's 2 to the n. N is my number of elements. So here I have 3 elements. That means I have 2 to the 3rd elements, which is equal to 2 times 2 times 2, which is 8. So I should get 8 subsets. Let's go ahead and list them. Well, the subsets are going to be first my empty set, or the null set, then the set itself, A, B, and C, and then I start listing off my different groupings. So I could list all the elements by themselves. And now I've got 1, 2, 3, 4, 5, so I'm missing 3 more. If I write those out, I've got A, B, B, C, and A, C. So now I've got everything included. I can just double check. 1, 2, 3, 4, 5, 6, 7, 8. I know that I should have 8 subsets, so I've got them all listed.